This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The last type of question we could be asked, where we're asked to find the equation of a circle, is to find the equation when we're told that it touches the x or y axis. So the question we're asked in this example is to show that if the circle x squared plus y squared plus 2gx plus 2fy plus c equals 0 touches the x-axis, then g squared is equal to c. So first, if we just get an idea of what we're looking at, if the circle touches the x-axis, so if we draw our x-axis and our y-axis, so this is our y, this is our x, and let's say we have a circle here that touches the x-axis, so say this circle here, and we know it has a center at minus g minus f. What we can see here is that if I was to look at this point here where it touches the x-axis, we can see that our x value is minus g, but our y value now is 0. So once I've done that, what I can look at here is the distance between these 2 points. So the distance, you'll remember, the distance formula is the square root of y2 minus y1 squared minus x2 minus x1 squared. So that should be plus, not minus. Then if we have our 2 points, minus g minus f and minus g 0, then our x1 is minus g, our y1 is minus f, our x2 is minus g, and our y2 is 0. Filling these values in, y2 is 0 minus f all squared plus x2 is minus g minus x1 is minus g squared. So we get the square root of minus f squared plus 0 squared. So it's the square root of f squared, which is just f. But what do we know about the distance between the center of a circle and a point on the circumference? Well, that's equal to our radius. So this f has to be equal to our radius r. So now if we go back over here, we recall that the formula for the radius of a circle of this type is the square root of g squared plus f squared minus c. And I just worked out over on the right that this is actually equal to f. So this distance here, r, is actually equal to f, and that's also given by our formula as well. So I've taken that equation and I've written it down here. And what we can do now is that if we square both sides of this equation, so squared, squared, the square and square root cancel on our left, so we get g squared plus f squared minus c is equal to f squared. And if we subtract f squared from both sides, we get g squared minus c equals 0. So if we just add c to both sides, we get g squared equals c, which is the equation we were looking for. So next, we're asked using the following result from the previous question, so this question up here, find the equations of the two circles which contain the points A at 3, 4 and the point B, 5, 2, and which touch the x-axis. So before moving on, we're just going to label the equation that we found, g squared equals c, as equation 1. And then we're told that there are 2 points on the circle. So just like our previous questions, we're going to fill those points into our general equation to get 2 equations in terms of g, f, and c. And when we do that for the point 3, 4, so in this case you have x is equal to 3, y is 4. Filling those values in, we get the equation 6g plus 8f plus c is equal to minus 25. Let's label that equation 2. Doing the same thing for the point 5, 2, we get our third equation, 10g plus 4f plus c equals minus 29. Call that equation 3. So then, if we just group our 3 equations together and move down here, what we have in our first equation is we have g squared and c. So if we want to make something out of these 2 equations, we need to get rid of that f. We need to get rid of this f here and here. So what are we going to do? Well, if we multiply our equation 3 by 2, so we'll have our first equation, or equation 2 will be left the same, so 6g plus 8f plus c equals minus 25. If we multiply this equation by 2 and change the signs, so we'll have 10g multiplied by 2 is 20g, but change the sign to minus. 4f times 2 is 8f, but change from plus to minus. Plus c multiplied by 2 becomes plus 2c, but we'll change the sign to minus. And minus 29 times 2 is minus 58, but we'll change the sign to plus. Then, if we add these 2 equations here together, we can see that the 8f and the minus 8f cancel, leaving us with an equation here, minus 14g minus c equals 33. Our first equation was g squared is equal to c. So if we write that over here, g squared is equal to c, or just swapping the order, c is equal to g squared. Now if we take that equation, and in this equation here, replace that c with a g squared, we have minus 14g minus g squared equals 33. So minus g squared minus 14g minus 33 equals 0. Changing everything to a plus sign, we get the equation that I have here. G squared plus 14g plus 33 equals 0. And we can solve this equation, this quadratic equation, as usual, to find g is equal to 3 or g is equal to minus 11. So in our last slide, we had g is equal to minus 3 or g is equal to minus 11. Our equation 1 said that g squared is equal to c. So we can get what our c is just by squaring minus 3 in this case. So c is 9. Or squaring minus 11 in this case, so c is 121. Then the last variable we need is our f. So in the case where g is minus 3, if we take one of our equations, so say equation 2, this is equation 2, we have our g, we have our c. The only thing we're looking for is our f. So filling in those three numbers, the two numbers we know g is -3, c is 9. So filling those in, we have a g is -3 and a c is 9. We can work down, solving this equation to get what f is equal to, and we find in this case f is -2. And in the case where g is -11 and c is 121, again we take our equation 2, fill in the values we know, so we know g, we know c, simplify down our equation to get 8f is -80, or f is -10. So our answer is going to look like x squared plus y squared plus 2gx plus 2fy plus c equals 0. If we take our first set of values, g equal -3, f equal -2, c equals 9, we get the equation x squared plus y squared minus 6x minus 4y plus 9 equals 0. If we take our second set, g equals -11, f equals -10, c is equal to 121, our answer is x squared plus y squared minus 22x minus 20y plus 121 is equal to 0. So in this equation here and this equation here, we have our answer.